Hey, welcome back. Let's take a look at metallic bonds. Metallic bonds are found in the D block. This is where the transition metals are located. Remember, these metals have different oxidation numbers or different states. Let's take a look at how the orbitals are arranged. So before, if you remember, we would fill 4s, 3d, and 4p. And the 3d was here because it was slightly more energetic than the 4s. So we would go 4s2, 3d, 1 through 10, and there will be no p for the transition metals. There is an exception, however, for a few of these metals. One example would be chromium, and the other example would be cobalt. In these cases, we can see that the S does not have 2 electrons. In fact, it only has 1. This is because the energy level for these two is very similar. As the orbitals go across the D, they decrease in energy level. So, at some point, the further back or the further away it is, those energy levels are actually at the same level as the 4s. Therefore, some of the electrons are going to go in the d orbital instead of going in the 4s orbital, because that last orbital is actually at the same energy level as 4s. This only occurs in a handful of the transition metals. So, one of the biggest properties of metallic bonding is the fact that all these metals, as we talked about, have similar energy levels and they are delocalized, meaning they are not fixed to their charges. So if these little positives represent kind of like the atoms, and these negatives represent the electrons around each atom, we can see that all of these electrons are just going to float around. They will not stay attached to a particular atom. This is called the sea of electrons, the fact that the electrons are delocalized. This phenomena will give metals all of their properties. Metals can be ductile. This means that they can be pulled into wire. So it will start as one block and then be pulled through a die. They are malleable. Being malleable means that you can be hammered into a thin sheet. Both of these properties have to do with the fact that the atoms can flatten out to a monolayer because they are not rigidly attached. Their electrons flow, and so they can roll over each other. And then they are also great conductors of heat and electricity. This is once again due to the sea of electrons. Because the electrons can flow freely, they can move throughout. The movement of electrons is essentially electric current. Another way to phrase this is because the electrons can move freely, they are considered to be mobile. Thank you for your time. See you next time. Bye-bye.